All right, so this is a quick little addition to the part A part of the lab I forgot to talk about. And this is just a continuation of that moles and grams work. So here's a question. How many grams are there in 25 moles of water? Remember, a mole is just like an amount. So if you have like a whole mole of water, we could calculate that based on what we did before. Hydrogen has a mass of 1 gram. Oxygen has a mass of 16 grams. You have 2 hydrogens, so 1 plus 16 gives us a molar mass for water of 18 grams. That's if you have 1 mole. But this is saying, well, but what if I don't have a whole mole? Like a whole mole, 18 grams of water is actually quite a bit of water. What if I have like a drop of water or 5 drops of water? How many moles would that represent? So that would be less than a mole. So here's an example where we're saying, all right, I have a quarter of a mole. I have 0.25 moles of water. How many grams would I have? So if you see here, I've laid out the steps. You take that 0.25 moles of water, listed here, and you multiply, you basically set up a conversion factor where I say, all right, I know that there are 18 grams of water and 1 mole of water. If I multiply that conversion factor times the number of moles of water, I'll get my answer. So, and what happens here is when you do that calculation, oh, apologies, you do that calculation, technically these units here cancel one another. There's moles of water twice, one's on the top, one's kind of down on the bottom, and you end up with the number of grams of water, which makes sense. This answer, less than a mole of water, a quarter of a mole of water is going to be much less than a whole mole of water. All right, so then we do the same thing down here. So let's do another, I'll do another sample one with you. Let's say I have 0.25 moles of carbon. All right, so I'll start with writing that out. 0.25 moles of carbon. How many grams would that be? All right, well, set up my conversion factor. I know from before that there are 12, I didn't need to put those decimals there, 12 grams of carbon and 1 mole. So if I multiply across 0.25 times 12, that gives me a number of grams of carbon, which I do believe, if I'm not mistaken, is 3. And those cancel. So you need to just do the same thing for the next two. We have sodium chloride if I have a half a mole. We have calcium chloride if we have way small amount, 0.05 moles. If I go all the way back to sodium chloride, so then here's the preview of part B of the lab, which you can do once you return. It's a pretty straightforward piece. Basically, we're looking at solubility. Solubility is like, well, you'll figure this out, but it like essentially, basic idea is if some things will dissolve in water, some things do not dissolve in water. Let's think of some examples. Salt, we know, dissolves in water. Rocks typically do not dissolve in water. Otherwise, you wouldn't find rocks at the bottom of a river or on the ocean. Sand does not dissolve in water. How do I know? Well, I've been to a few beaches. There's sand at the beach. It is not going away. It's not dissolving in the water. So we're going to do a quick little test. And we're testing 3 different substances. Sodium chloride, which we should know that's table salt. You can predict what that's going to do. Sugar is one, and then calcium carbonate is one. You're going to do those 3 things to see if those 3 dissolve in water. And the simple test is we put a little bit in the water, stir it around, see if it goes away. That's really it. And the last thing that we did is I did a little preview. Once students did that, they took their pictures, got that in here. Is we did a little, all calculated its molar mass. A bit of a preview. Well, obviously you'll have to answer these questions, but you can't do that until you've got the lab. Did a little preview of the next thing, which is then talking about, okay, we're kind of combining part A, which was about moles and the amount of stuff, with part B, which is about dissolving. And we're looking at this idea, this term of molarity. Molarity is really how much stuff is dissolved in water. Or anything that's doing the dissolving, but usually it's water for us. And so, like, what does that mean? Well, you've had concentrated solutions, and you've probably heard of, like, made from concentrate. Maybe you've seen those little orange juice containers that, like, you can buy orange juice in a little, like, frozen, almost like a frozen can. And then, I don't know, maybe you've seen this or not. And then you, like, tear the thing off and you put that into a big pitcher, and then you add water, and it dilutes it. So concentration is really just about how much stuff is dissolved in water. Another way to think about it is like I could have a flask, or I'm sorry, a beaker. So here's my beaker. It's not a very well drawn beaker. I'm not loving that, but oh well. Here's my beaker with water, and I could put like literally one little grain of salt in that water, and it would dissolve. And that would be a pretty dilute solution. There's one salt grain in there. In fact, it's probably so dilute that you may not even taste one grain of salt. Versus if I put like a whole tablespoon of salt, dump that in to our beaker, you suddenly have created a more concentrated solution. Guarantee you would taste that. So when we're talking about how concentrated something is, we typically use this term molarity, which of course kind of has that word mole in it, and it just has to do with the number of moles of a substance per liter of water. That's really it. So in the first question, how many grams of sodium chloride do you need to make 1 liter of a 1 molar solution? Well, I think if I go, so if I know its molar mass, which I do believe is like 48 grams per 1 mole. So if I get 48 grams of sodium chloride, I will have 1 mole of sodium chloride. So if I take that 48 grams and I add it to my beaker, I will have what is described as a 1 molar solution of NaCl. The other way to look at that is I need 1 mole of NaCl. Do my conversion factor. I know that 1 mole of NaCl is 48 grams of NaCl. I do the calculation. Seems like a little redundant. 48 grams of NaCl. I know that that's what goes into my 1 liter solution. That's all. So we did all these. We previewed this today on Wednesday. On Friday, we're going to do some of these calculations. moving on to this page, we're going to look at, it's just a sequence of calculations looking at number of moles required or number of grams required to make different solutions.